So for question number 5, we have an annuity that pays 1 at the end of each year for n years. And then once we accumulate that all the way up to time n plus 1, it's going to equal to 13.776. And then we're given extra information about the interest rate, and then we need to find n. So first of all, let us just summarize the information given. So we know that 1 plus I to the power of n is equal to 2.476. And then we're also told that if we have n payments, so this is an annuity immediate, and then we accumulate everything up to time n plus 1, that amount is equal to 13.776. So let's try to express all this in terms of symbols. So what is the accumulated amount we have at time n plus 1? Well, the amount we have at time n, that's just equal to Sn, right? That's by definition, that's the accumulated value. And then if we want to accumulate up to time n plus 1, we just multiply it by 1 plus I. So this is the amount at time n plus 1, and we know that that's equal to 13.776. And so we can write this out using the formula. And then we're given that 1 plus I to the power of n, that's equal to 2.476, right? So I can actually take these numbers and divide it over to the other side. And then if you do that with your calculator, you'll find that dividing both numbers, that's equal to 28 over 3. So now we have a nice equation where we can find I. So 3 plus 3i, so continuing here, we're multiplying over to the other side, is equal to 28i. 25i is equal to 3. So I is equal to 3 over 25, that's equal to 0.12. So once we found I, we can actually find n really easily. So we know that 1 plus I to the power of n, that's equal to 2.476. All we have to do is to take the logarithm of both sides. So it doesn't have to be a natural log, I'm just using it because it's easier to, it's one of the numbers one of the functions you can find on a calculator. So it doesn't have to be natural log, it could be log or something else. So let me just get rid of that. So don't forget your log rules. Log a to the power of b, that's equal to b log a. So that's why I'm able to pull the n out of here. And so n is equal to log 2.476 divided by log, and then we know that I is equal to 0.12, right? So 1.12. So substitute everything into a calculator, you find that n is actually equal to 8.